So now if I go over there, cool. All right, that should be working now. And it'll be on like a, cool. All right, that should be working now. And it'll be on like a 5-second delay. All right, that should be working now. And it'll be on like a 5-second delay. All right, that should be working now. All right, so that is the on like a let's get a link to it. All right, that should be working now. All right, so that is the on like a let's get a link to it. All right, that should be working now. All right, so that is the on like a let's get a link to it. All right, that should be working now. All right, so that is the on like a link. Let's get a link to it. All right, that should be working now. All right, so that is the on like a link. Okay. And I don't know if that link will be preserved through classes, but there we go. All right, so actually let me stop recording and then I'll delete this recording because this is not very interesting. Show recordings, delete. SSH client. How do you use it? Okay. All right. Okay. There. All right. You guys all set? I'd recommend watching on Discord. The YouTube channel is apparently about 5 seconds behind live. So it'll be a little disconcerting if you're trying to watch both. Okay. So that should handle the, because Discord is a 50-person limit for who knows what reason. It used to be 10, I think, or something like that, but they bumped it up for classes. Okay, so let's see what we got here. Somebody's asking a question in Help Center. I'm getting bad input, but the test is giving an answer. Homework test 8. Should it be bad input? All right, let's just answer some homework questions. So go ahead and post any homework questions that you guys have in the lecture room. I will start recording. All right, welcome to day 2 of CSCI 41. Let's go ahead and answer some questions about your homework first. So the first question I got was, is test case 8 supposed to be bad input or not? So let's go into my solution for fractions.reference and look at input file 8. And so yes, this is supposed to be bad input. That is not a number. That is 12 squirrel. It's not actually a number. And so what a lot of you guys might notice is that your code actually will handle it. And I made this test case deliberately and maliciously to see if you guys could figure out how to handle it. So that's a cup of student tears right there. So the if you just do CN, you will get 42, and then if you CN an integer again, you'll get 12, and then you're done, and you don't know there's a squirrel waiting for you. And so the do we have to put our code on our own files, or do we just use one for fractions? I would just edit main.cc, honestly. The easiest way. I made a separate file because mostly I just wanted to show you guys this work of beauty right here. But most of my code is actually in this file here. You can split it, and I can show you guys how to split files, in fact, in this lecture. But let's talk about input file 8. So best way of handling this kind of input, and some of the other possible bad inputs would be like 3.1, that's a bad input. -1 is bad input. 0/6 is bad input. Is to read these things in as a string. Read them in as a string. So there's a couple different functions you can use to do that. Let's go back out and let's talk about input, because processing input is one of the most important things in computer science, and it's one of the most annoying. because users can type anything, right? Sometimes their cat will walk on the keyboard. And so if your code crashes, if somebody's cat walks on the keyboard, it's your fault, not the cat's. So let's talk about input. So, all right, let's talk about input. So this is how probably a lot of you guys are reading in the two fractions, something along those lines. You have a prompt and everything, but it's along those lines, right? And I'll just print out something. So if you run it and we do 5 divided by 6, we get 0. We go 10 divided by 3, we get 3. Over integer division drops all decimals. And so the trouble with this is that if you type in 42, 21, sorry, that's 2, right? 42, 21 squirrel, it's still 2, because what happens? You guys are ready to know what happens when you do this. When you do a double right arrow, what it does is see if the first letter is an integer. If it is not an integer, then an error occurs. Nothing gets written into X. We could probably initialize these values, right? And so if nothing gets written into X or Y, in that case, squirrel, then they're left at 0, and it does a division by 0. X 0 divided by 0 is 0, and so it'll crash. So one thing that is a good habit to get into is to check to see if an error occurred. So if an error occurred, you can check that using this. Use if not cn is a way to check to see if an error occurred in your input, or you can say if cn.fail, which is the equivalent of that. If an error occurred, then I don't ever bother typing fail. I just use if not cn. If an error occurred, then cout error. My name is error. There you go. Anyone know that references? Anyone know? My name is error. Zelda 2. Very good. Yeah. It probably, I think there's a villager in a town somewhere who's, I am error. So I think they forgot to I don't know, put in the name for the villager or something. Classic game. Zelda 2 is an interesting game too. All right. So if we run this code, then actually I'm gonna, yeah. If I type in 21 squirrel, then it prints out my name is error, right? So what happened here though? What happened here? So if I typed in 21 squirrel, it's actually going to read 21 into X. Okay? It actually does an error. So I could actually cout X. 21 squirrel. It actually reads 21 into X, because what happens is it checks to see if the first letter is a number. If it's not a number, like if all we typed in was squirrel, then it immediately throws an error. But the cn into X actually went through just fine because the first letter was a number. Yeah, the first character was a number. And so if the first character is a number, it will not throw an error. It will just simply keep reading integers until it gets something that is not a number. That's how cn works. Cn works by reading ints until it reads a non-integer. Okay. So because it started with a 2, it's good. There's not going to be an error, and it will simply keep reading numbers until it gets a non-number, and then it stops, and it leaves squirrel in the input buffer. And so what's causing the error here is when we try reading y. When we try reading y fails because the first letter of that is not a number. It throws an error. It prints my name is error, and the rest is history. So with your code, you're doing something like this, right? And the input is 42 and 21 squirrel. And so what happens is that it reads 42 into X. Make the font a little bit bigger for you guys, maybe. Appearance, font, it's up to 24-point bold. There we go. Okay, so if we type in 42 for X and 21 squirrel for Y, Y gets the number 21. An error does not occur. Because it reads the 2, it reads the 1. S, no, that's not an int, and it stops there, and it puts 21 into Y. So, how do we handle this? Well, the way I would do it is by reading strings instead. It's the easiest way to do it. Okay. Strings almost always will not cause an error. It's very rare for an error to occur when you read a string. And the trouble is, though, is that you now can't do division. It doesn't make sense to divide a string with another string. And so what you might want to do is string S1, string S2, read in some strings. Again, you're going to need to put the prompts in there. Please enter a numerator, please enter a denominator. And then you could say int x is equals string to integer, or string to long, or string to long long. I'll just use string to integer for now, even though it's a hint, that's wrong, for one of the test cases at least. So we will convert string 1 into an integer, and we will convert string 2 into an integer. Okay. So now if we do this, 42, 21 works fine. 9 divided by 4 is 2, with a remainder of 1, right? And if we type 42, 21 squirrel, it works, but it doesn't throw an error. Now, so how do we check to see if we have a non-digit? So in the string, there's a header file called CSCI, and you can use CSCI to determine the nature of every character in a string. So you can do something like this for every character in the first string. Has anyone here not seen range-based for loops before? Has anyone not seen range-based for loops before? This is a modern C++ construction. This does not exist prior to 2011. 2011 was a watershed year for C++. They radically changed the language. If you studied C++, I know somebody in this class told me they haven't studied it in 7 years. You probably haven't seen this before. 7 years ago was 2014, and there's a good chance that your class wasn't up to date then. Okay, so let's talk about range-based for loops. Then, a few of you guys have not seen them. So what this means, it's a for each loop. What this means in English is for each character C in the string S1, do something. So for every character in the string S1, that's what that colon means. Okay. And I prefer range-based for loops over the traditional way. This is kind of the same thing as for int I equals 0, I is less than S1 dot ling I plus, rather than doing that whole thing, I prefer this. Okay. So for every character in the string, let's just start off by couting it. Let's see out the letter. Okay. So for every character in S1, we'll just print the letter and then hit the enter key. Okay, so if I type in 21 squirrel and 42, you see it prints the first letter, then it prints the second letter, then it prints S, then it prints Q, then it prints U, then it prints I. Do you guys see how useful that is? So it says for every character C in the string, print C followed by the enter key. And so it vertically prints the string. Okay. And if that makes you sad, then I will put a happy face emoji in there for you guys. There. 21 squirrel. There you go. So 2 with a happy face emoji, 1 with a happy face emoji, S with a happy face emoji. There you go. Be happy. It's a shorter means of writing a for loop, sort of. Yeah, it's useful when you have a string or a vector or some other container class, and you want to do something across the entire container. So for every letter in the string, which is usually what you do. But if you don't want to do it, like if you only want to check the first 5 letters of the string, then you would have to use a normal for loop for that. For each loops go across the entire thing every time. But it's nice because you don't have to worry about going out of bounds. They can't go out of bounds. And it's a lot shorter to write. It's a lot more readable. So for every character in the string, print the character followed by happy face. And so if we wanted to vet this input, if we wanted to make sure there weren't any letters in here, we can say if not is digit C. So if that character is not a number, then see out that input. Something along those lines. Or you'd call die. So if we type in 2121, it's fine. If we type in 21 squirrel, then it prints bad input a bunch of times because I'm not quitting. So you would just call die. Die would print bad input and quit. Okay. Does anyone remember how to bring colors back to the server, or have I become colorblind? Okay. Looks like you got colors on here. So, any questions about range-based for loops? So this is how, again, instead of that, just call die, right? Die prints bad input and quits the program. So that's kind of how you can go through the string looking for anything that's not a number, because it has to be a number. And then you also have to vet it to make sure the number is greater than 1. And I'll just tell you right now, string to integer isn't quite good enough. That'll get you to 9 out of 10 on the homework. The one of the test cases needs a long instead of an integer. And so a long is a 64-bit number. Another way you can do it is by saying int 64p. It's kind of the way that I prefer it. That is a 64-bit integer. A normal integer is that. That's a normal integer. 64 bits gives you a bigger range of numbers to work with. One of the numbers that I give you is above the maximum integer value. And so string to integer doesn't work with it. And so you have to use string to long. So there's a function called string to long, and that will work with a 64-bit number. So, your code's timing out. Yeah, you're probably doing something wrong. Actually, you're not. Probably. Maybe you have an infinite loop. It's possible. There's a lot of reasons why your code could time out. 2-second timer gets timed out. You might be infinitely looping. Your code just might be slow. So yeah, those are both possibilities. All right. So test case 5 you're looping on. All right. So it's 2 divided by that's the 1, right? This is bigger than maximum integer. So this, however, is a reducible fraction, right? 2 divided by an even number, you could reduce that to 1 over 2 billion and change, right? And at any point when you have a 1 in the numerator of the target number, you're done. Just print the number, you're done. You don't have to count from 1/2 to 1 over 2 billion. You're done. The numerator is 1. You're done. Yep. Just giving out all the answers today. Right. So if the numerator is ever 1 in the user's input, they ever type in 1 over, whatever, that's the answer. You see how my code didn't have to count up to whatever the hell number that is? The numerator is 1. Done. Okay. If I type in 2 over that, it reduces the fraction and then prints the answer. So, do you guys remember how to reduce fractions? Do you remember fractions? Do you remember finding a common denominator? I know I didn't. I was like, I kind of do, but it's like, dusting off some brain circuits from, I don't know, 3rd grade, 4th grade, whatever. The gears in my brain turned slowly on this assignment. Like I was like, I know what I'm supposed to do, but like, how do I do it? Creak, creak. And what's really mind blowing is that the ancient Egyptians were doing this 3,800 years ago with no computer whatsoever. Papyrus for fun, to train, maybe to train people to get, their mathematical scribes. I don't know what they're called, up to speed, but they were just doing this kind of stuff for fun. They're just puzzles. Yeah, not that bad by hand. Some of those fractions got really big, right? So that alien technology, fun. Yeah, you guys have to do it for work C's. Okay. So what else can we talk about with input? For output, one thing you might want to do is not see out things, but rather create a string. So what I did for my thing was I created a string called retval. So instead of doing this and like printing, a number or whatever, what I would do is I would say retval plus equals. You guys know this with strings? It's um, and then at the very end, I have a single cout statement. And so the reason why I do this is because the first time I did it, my output looked kind of like this. It looked like 5 comma 3 fourths comma, or actually be 1/4 or whatever, 1/4, 1/8, and then it would look like this, right? So there'd be this extra comma and space in my string, which was really annoying. And so what I did was I would just rather than see outing things immediately, I'd this code here appends to the string. So it adds to a string. So what I do is create this string called retval, and then I just append each of the terms to it. And at the very end, I would delete the last 2 letters. So let me first run this for you, just so you can see that this is a very broke way of doing hello world. There you go. There's hello world. And I can yeah, end line on it there. There you go. Hello world with extra steps. Did we ever verify they did it right? Yeah, they did almost. There's a mistake on one of them. The dude made a mathematical error on one of them, and he was close, but he was like off by a digit or something like that. But yeah, all the other ones on the Ryan mathematical papyrus are all correct, which is mind blowing. Right? I can prove I used to play the bass guitar, but I never played it right. I just smacked the strings and it made funny noises. Yeah, that's me on the guitar too. I don't know if you guys can see the. Yeah, where'd it go? There used to be a guitar back there somewhere. Right here. Yeah, there you go. It's just for video games. 3.14 is pi. Yeah. So, okay. So, do you guys understand this? That you can append to a string by. Thank you. So, you can append to a string that way. And so, what I would do is I would append a term and then I'd always add the comma, space, comma, space, comma, space. But before I did the close curly boy, I would do this. I did retval dot pop back twice. And then I would add the curly boy to the end of it. And so pop back deletes the last letter in a string. So that would delete the space, it would delete the comma, and then I'd put the curly boy on there like that. So if I did that with hello world, you'll see that the exclamation mark and the D vanish. So there's a function called pushback that will add a letter to a string or a vector, but I repeat myself. So I can push back the letter Q. Right. That'll add the letter Q to the end of the string, and then if I pop back, it'll go away. Okay. So push back adds to the end of a vector or a string. Pop back deletes from the end of a vector or a string. Okay. Any questions about these two things? It appends one letter. You did it with vectors? Yeah. A string's a vector. A string is just a vector of characters with like some little extra sprinkling of magic put onto them. You can't see out a vector, right? You cannot see out a vector, but you can see out a string, right? So there's extra magic added to strings, but they're basically just vectors. Everything you do with a vector, you can do with a string. Can you put a 2 into pop back to make it pop back twice? No. How do I see out a vector? Yeah. How do you see out a vector? So you use a range-based for loop. For every element in the vector, print that element followed by an inline. It's like literally what I just showed you guys earlier. If you wanted to make it pop back 10 times, yeah, at a certain point, though, there's a function called erase that you can use to erase blocks of a string or a vector. But yeah, you can do a for loop. Parent I equals 0, I is less than 10, I plus plus, retval dot pop back. And it prints out, hey, because we deleted the last 10 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so hey is all that remains. Pushback Q added a Q. Yeah, so let me show you what that looks like. So if I say retval dot push back Q, then it's now hello world Q. No relation to Delancey's character in Star Trek or the QAnon conspiracy. It's just the letter. Does it make a big difference if the plus plus is before or after the I? No, it don't. It don't. Some people prefer it one way. Some people prefer it the other way. Some people falsely claim it'll make a difference in performance. It won't. Um, an optimizing compiler will remove the creation of an unneeded temporary. And if you care about the performance of your code with the optimizer turned off, you're caring about the wrong things. I do not worry about things that a compiler will generate the same code for. I care about how my code looks, and I use I++. So the question was, you guys aren't following. Some people say this: parent I equals 0, I is less than 10, I++. Print hello world. Okay, so this is how you do for loop. Your standard for loop. 10 times, it will print hello world Q, I guess. And so the question was, what if you did this instead? And the answer is there's absolutely no difference. So, okay. Plus plus is sometimes faster than I++. In this case, it will make absolutely no difference. And it's purely just whatever you prefer. I do I++ because the language is called C++. It's not ++ C, okay? The language is C++. So I do I++ for that reason. Okay. And I don't know if I've told you guys this before, but C#, it's called C# because it is C+++++, right? Take the 4 pluses, put them into a hashtag. There you go. It's C++++. You're not learning the ++ C language. You are in the wrong class. Yeah, sorry. Can you change the int to like a double? Like in the for loop or like here? Yeah, sure. I wouldn't, but you could 10 times. The trouble is that when you add to doubles, you get error, and so for small numbers like these, it won't come up. For bigger numbers, it might. Doubles only have a certain limited amount of precision in them, and so when you get big enough, you might have an off by 1 error due to it rounding. Like it might round to 9.9 instead of 10, or it might round to 9.9999999 instead of 10, and then it'll do an extra iteration. So I would never use a double in a for loop like that. Yeah, we use integers when we want our code to behave the same way every time. Doubles are used like scientific computations and things like that, where you're like you have real world measurements and you're averaging things and stuff like that. But good question. Yeah. Are there some scenarios when putting the ++ first will make a difference, like in variables out of a for loop? So if you have a pointer to something, let's say char pointer is equal to retval dot data. So this pointer is now pointing to the first character in retval, and it might get invalidated by this. Let's do this here. And I see out pointer. What is this going to do, first of all? So I don't use pointers very often. Modern C++, you can more or less get away with not using pointers, except in some cute scenarios where they are useful. So that is this dot data thing here is the memory address of the first character of the string. And so this pointer holds the memory address of H. And so you would think this would print a memory address, right? Invalid conversion from const char star, yeah, thanks. Const char. Nope, it prints the string. There is a special overload for pointers, character pointers, where it does not print the memory address. If it detects you're trying to output a character pointer, it will print the string. It'll print a string. So starting at H, going to the end of the character, it will print the string. Now, what if this? See if that'll contain it's going to be Let's see. Do something kind of ugly here. Well, not like that. Yeah. So we're going to strip the constantness away from it, so that will allow us to do this. Okay. What the hell's happening here? What the hell is happening here? Okay, all right. So what we had before was this code here returns the memory address of H. And this ugly ass thing that I added here removes it being constant, because you're really not supposed to do this, but I'm going to show you anyway, even though my brain hurts a little bit right now. Okay, so it's the same code essentially. If we just output this should work. There we go. It still prints the string. And since you guys are probably crying right now, I'm going to put QQ at the end of it. There you go. Hello world QQ. Now, watch this. Pointer plus plus. So pointer plus plus will move the pointer to point to the next thing in the string. What is the next thing in the string after H? What is the next thing in the string after H? It's E. And so if we compile this and run it, it's now Cockney. Hello world QQ. Hello. The string's still the same. I haven't modified the string at all. And people do pointer tricks like this all the time. Unfortunately, I think they do it too much. My sister took a C++ class. She took this class actually last semester, and I was helping her with it. And the professor loved doing pointer things like this. And I was just like, not a fan. Not a fan of it. There you go. So what we have here is we have a string, and we have a pointer into the string, and we can move the pointer 3 times. So it's the pointer, instead of pointing at H, let's move it 4 times. Why not? What letter is the pointer pointing at now if we move it 4 letters to the right? What letter is it pointing at now? I'm moving it 4 letters to the right. To the right, to the right, to the right, to the right. It's the opposite of Beyonce, to the left. So without modifying the string at all, I can now make it print, oh world. Oh world, you're my favorite. Oh captain, my captain. And so some people love doing this kind of stuff. I'm, not a fan. Not a fan. But there you go. So we could create kind of a new string without actually creating a new string and without modifying the string at all. Anyhow, to come to the point, pointer plus plus, when you do that, it creates a temporary pointer, and then it copies the value into the temporary. Again, if you have an optimizer turned on, I don't think you're going to see any difference in the code. But let's find out. It's a good question. And let's go to Godbolt. Godbolt. Which is the guy's name. The guy is from the Godbolt family of the New England Godbolts. Dude's name. Godbolt. And so let's go ahead and do this. And then on the right-hand side here, we're going to do the same thing, but we're going to do it with plus plus pointer instead of pointer plus plus. And let's see if this is going to generate different code. All right. Does this generate different code? So on the right-hand side here, we've got 365 lines of code. On the left-hand side, we've got 367 lines of code. All right, there you go. There's your answer. Let's turn on the compiler optimizer. Where are you at? There we go. Where's the thing? Compilation failed. I can't read what's in here. Okay, so this is the actual assembly generated. You said before I was speaking the language of the gods. This is the language of the gods. All right, so let's come down here. See if we can find where that line is. Yeah, the point is, when you do it this way, it creates a temporary, and that could generate a couple extra lines of assembly. In general, though, it's not something to worry about. The main difference between the pre-increment and the post-increment operators, if you combine it with something. So if you say like char star pointer 2 is equal to plus plus pointer, then this guy is pointing at E. Whereas if you did it with the post-increment operator, the plus plus after it, the pointer 3 is pointing at H, actually. So when you do this, it moves the pointer to the right prior to copying it to pointer 2. And this one copies it to pointer 3 and then increments it after. Oh, actually, sorry, that pointer moved, so. It's technically pointing at E also, because it moved here, right? And then after this line, pointer afterwards points at L. So anyhow, that's way too much information perhaps for your question. The answer is plus plus is faster. And if it actually matters, then change it. Most of the time, the only difference between plus plus and before and after is this modifies it before copying it, and this modifies it after copying it. That's the difference between the before and the after. In a for loop, there's no difference. With the plus plus I and the I plus plus, there's no difference. It'll do the same thing. All right. Live video is gray screen for half the time. Let's see here. See if my backup is running. No, backup's not running. Basically, the cool kids use plus plus before it. You'll see professors out there telling you to always use plus plus just because it's faster. Because when you do this line here, what it does is it has to make a copy, and then it moves the copy into pointer 3, and then the original gets updated. And so it's smallest fraction of a second slower. And so that's why some people just prefer plus plus, because it doesn't have to make a copy. But that's the That's the long and the short of it. So you'll see people just use plus plus all the time for that reason. Okay. Way too much information on that. All right. So I don't like pointers. I don't use them very often, but you do need to know them. You do need to know them. Okay. All right. Okay. What other questions do you guys have? If you want, I can lower the video quality on Discord. Let's see if that'll help. Let's turn it down to 1080p and see if that makes a difference. 1080p, 30 frames a second. I'll lower that. See if that helps. How do you copy and paste again? Great question. So if I see out hello world, if you want to copy and paste this, YY copies the line and P pastes the line. So YY copies the line. Y5Y copies 5 lines. P pastes below. Capital P pastes above. YY7 Shift P pastes 7 lines above me. The quality was at 4K 60 frames a second, so that might have been a little too much. DD deletes. Yep. Cool. Hardware acceleration. Interesting. Okay. So, any other questions about the homework, about life? We got 40 minutes left in class, but again, this week we're just reviewing CSCI 40 because I graded all of the competency exams as of 4 o'clock in the morning. I was up late last night grading them, and about half the class I think has some gaps in their knowledge. And so, like I said, I really don't want people to drop out of this class. I want to fix the gaps rather than just being like, "You're not worthy, begone, foul peasant," which is the attitude my institution has. I think they see this class as the filter class where the unworthy are purged from the rolls, and only the anointed ones with oil upon their brows can ascend into the ranks of upper division computer science. Like, legitimately, that's why they don't articulate this class at UC San Diego. It's because they want people to take it so that they can filter out the people that don't belong. Elitism in computer science goes hand in hand. It's funny. You got to be maybe a little bit elitist, because every computer scientist has very strong opinions about what's right, what's wrong. A lot of professors will be gasping in outrage at me using namespace standard, their monocles flying out of their face. How dare you, sir, using namespace standard? What are you, a peasant? Is it that bad? They think so. It's not. So they love writing code like this. They love writing code like that just has STDs everywhere. They love STDs. And if you go to Irvine, UC Irvine has a web page on their computer science. One of the professors, at least, has this like 5-page long rant against using namespace standard, saying it's better for you to write that way because now you know that you're talking about the C out in stood rather than some other C out, because anybody can make a C out and you just don't know which C out it is when you don't qualify that. You know how many times in my professional career I've seen somebody create their own C out? Never. People will make their own logging devices and things like that, but they don't call it C out. You know why? Because it's dumb. How many times have they made their own inline? Never. You don't. This doesn't tell me anything. This doesn't tell me anything. I know where it is. It's in stood, right? If somebody does make their own POW function, like they make an optimized or parallel POW, then I don't import that namespace, right? So if somebody like boost is a thing, and so rather than boost POW or whatever, um, rather than importing that namespace, I would just leave it like that. I'd say boost POW, to boost squared or whatever, right? But the stud namespace, importing the whole thing has literally never caused me a problem in 20. Well, it hasn't existed for as long as I've been programming. It's literally never caused me a problem. Literally, have I never been burned? Ever, never, ever been burned by using namespace standard? Ever. I have been burned by forgetting to type this, right? So if I don't have using namespace standard in there, this code won't compile. Error. Cout was not declared. Did you mean stood cout? Yes, I did. And then I have to come back in here and put the STDs back in. Also, it's garbage. I'm sorry. Typing 5 extra letters with colons everywhere, that slows down your eye's ability to read the screen, right? Like it, like look at the difference in size, right? The more things your eyes have to parse, the slower you can read the code. I'm sorry, it's just true. Like I've trained my eyes to skip over it. Yeah, but your eyes still have to go through here. Like discard, read, discard, read, discard, read. Like it slows you down. I'm sorry. Like it slows down your readability. It slows down your writing of code. It's not as this is far more clear than this, and I will. This is a hill that I will die on. I'm sorry, but like to be fair, 90% of computer science professors disagree with me. So you know, be aware that when you go to another institution, you're going to have to get used to STDs. Okay. I don't like STDs, but other colleges, like, they're just full of STDs. So there you go. Yeah. And you can read these long rants that professors have made. It's a bad habit for students to get into. The one place where I will not use using namespace standard is in a header file. So in my header file, there's no using namespace standard. And the reason for that is because when you include a header file, it just copies and pastes all that code for you. And if somebody else doesn't want to use namespace standard, I don't want to make them, right? And so in my header file that I made, you see there are STDs everywhere. Okay. Because I'm sharing that with the world. You want to share STDs with the world. That's the rule. Okay. So you can see there's just STDs everywhere. It's publicly available. So STDs galore. All right. But for my own code, no. For my own private business, I don't want STDs up in there. Um, Bridges has using namespace standard in their header file. So more power to them. This conversation would sound bad to somebody not in computer science. Why? They don't like they like you know they don't like STDs or something? Okay. So good questions. Good questions. Let's go over. Uh, let's go over. Let's see the range-based for loops we kind of talked about. Pointers I talked about enough to scare you away from them for life, maybe. Let's talk about classes. So let me kind of give you an idea of what I did with my fractions class. So class defines a new type. One thing that everybody forgets about classes is that a class definition ends in a semicolon. Ends in a semicolon. Everybody forgets that. Okay. And by default, everything inside of a class is private, so it's not accessible to things in main. So if I'm going to make a very simple class for fractions, I would create a class like this named fraction. I would create a public section. Public means main. What public means is that people outside of me can see it. Yep, that's what public means. Okay. Numeration. Numerator, denominator. There you go. And so this is a very, very simple fraction class. And so this design, which is fine, honestly, like, you know, I don't want to get involved in holy wars. I'm actually not somebody who really cares very strongly about doing it one certain way, because I've worked on a lot of different code bases. I've seen different companies and different institutions have wildly different style guides, and this is the right way of doing things. No, 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 this is the right way of doing things. I don't care. I'm here to teach you guys different ways of doing things, and then you can decide for yourself what you love and what you hate. Right? It's like real life. So this design here is called plain old data. Yep. We call these things pods sometimes, or sometimes the plain old data structure is another way. Is another way they do it. Plain old data. Okay, and so this is just a class. This class is just 2 ints. That's all it is. Well, it's just 2 ints. I never knew what professors mean by people outside of me. Like if somebody has your code or is looking at it, they can't see private or public variables. Just more confusion. So what this means is outside of my curly braces. And see this. Okay. So that means if I come down into main and I make a fraction f, I can say f dot numerator equals 2 and f dot denominator equals 3. And this code will compile just fine. Okay. So that is cool. Now, what if I put this into the private section instead? Only code within my curly braces can see this, or friends. And we'll talk about friends maybe today. So if I were to move this code into the private section, now this code will not compile. That's what it means by it can't see it. Like obviously, if you share your source code with people, they can see it, right? It's not like you're changing the font color to black, right? What this means is that main is now no longer aware that numerator and denominator exist. Okay, so you cannot access it directly. It is a private member variable. Okay. So if whatever you put into the public section is your interface, that's what it's called. Anything in the public section is your interface. I'm like, this is what I'm exposing to you guys. You can call this and this, but things in the private section you can't call. And there's a lot of good reasons why we do that. And that's our topic for, the first 2 weeks of school. I'm not quite going to get into the reason why yet, but there's good reasons why. Okay. So this class right now is useless. This class is useless. The reason why it's useless is because everything in it is private. There's nothing that can be done with this class. There's, maybe some C++ mavens that are out there that know that there are uses for private only classes, but they're obscure. Okay. So C++, by the way, defaults to private. So a class defaults to private. So if I delete the private tag, it's still private. See, code still does not compile. So in C++, the classes default to private. Will we go over recursion? Yeah, maybe not today. So what is the advantage of using a class over a struct? So let me write this down here. The only difference between a class and a struct is that structs default to public, classes default to private. That's the only difference. So if I were to change this code here from class to struct, nothing changes because numerator and denominator are still private. So nothing changes. It'll compile exactly the same way. There was a bug in old versions of Visual Studio where they would actually compile the code differently if there were a struct in a class, but the only difference between a struct and a class is if you don't put any tags in it whatsoever, if I did this, now the code compiles. You see that? Because structs default to public. So everything inside of a struct by default could be seen in main. Main could access it. Now, that said, even though class and struct are exactly the same, except their default privacy settings are different, cognitively, to a human, they're different. And one really important concept I want you guys to get is that source code is for people. Okay? Computers actually can't read source code. That's why you need a compiler. The compiler translates human readable source code into something the CPU can understand. Right? CPUs don't understand source code. Source code is for people. And so this is like one of my great theses is that when you write source code, it should be readable by people. Like people should be able to look at your code, be like, oh, that's what he's doing. Because most code isn't. Most code is not readable in the slightest. And partly that's the fault of the language. Partly that's the fault of the language. But when an experienced programmer, let's say, when an experienced programmer looks at struct, I'm expecting to see something that looks like this. When I see you use the struct keyword, I'm expecting you to be making a plain old data type, where it's just a couple different variables living together. When I see the word struct, that's what I'm expecting, because struct has the connotation to experienced programmers of just, an agglomeration of variables together. That's the connotation that struct has. Class has the connotation of not being plain old data. Class has the connotation of having private and public sections and an interface, and it's this kind of thing that we're going to talk about over the next 2 weeks, like how to properly design a class. Okay, and so there's a human connotation to struct and class. Experienced programmers use struct for pod types. So that's, and there's nothing wrong with plain old data. Like we use it all the time, but that's kind of the connotation. Does that make sense? The cruel CS thesis. Evangelion. Yeah. So, again, that might be a little bit too much of an answer, but structs and classes are our topic for the next couple weeks. So, no worries. Okay, so how do we get at numerator and denominator if we're using proper class design? Okay, so the first thing we do is we write get and set methods. So a get method returns a value from the class, a set method sets a value on the class. And so you can have something like this, get numerator, and all this function will do is return numerator. I'm really regretting having a long variable name now. And get denominator, return denominator. Okay. Remember that semicolon at the end of the class. Don't forget that. Okay, so if I wanted to, I need set methods as well. So a set method will set the numerator or the denominator on a class. So void set numerator, taking in a new numerator. Numerator equals new numerator. All right, watch this. Are you guys ready for some Vim magic? So, how many letters in is numerator and denominator the same? I'm counting 5. Numer. Sounds like a city in Iraq, right? Numer. And then the ater is the same. Okay. So that's five letters. So I'm going to type 5S. S means substitute. 5S, and it deletes those 5 letters and it puts me into insert mode. So I'm going to type denom and then hit escape. Okay. Now I'm going to move my cursor over to the start of new numerator, and I'm going to hit period. Period means do the last command you just did. Or if I want to be even more cool, /numer searches for numer, and I hit dot. N for next, dot again. Takes longer to explain it than it does to do it. But whenever I do a Vim trick, I explain it to you guys, so you can gain the benefits of it. Was the last question of the competency exam purposely put in replace mode? I don't think so. There's no replace mode. Probably hit insert or something. Stuck in class has a lot to do with OOP. Proper class design is, object-oriented programming. That's our topic for the semester. Okay. So now that I got my getters and my setters, notice that I still can't do this, right? I still can't just say f.numerator, f.denominator down here in main because it's hidden. It's private. Only you have access to your private members, right? You and your friends, right? So what I have to do instead is say f.set numerator to be 2. And f.set denominator to be 3. Yep. And then that will, the reason why this works is because get numerator and get denominator and set numerator and set denominator, they're all in the interface. They're in the exposed section of your class. You're saying, if you're going to be modifying me, here's how you do it. You can't set my member variables directly. You have to go through the interface. And there's a lot of really good reasons to do that. For example, in your code, fractions can't be less than 1, right? None of the terms, neither numerator nor denominator, can be less than 1, right? And so if you allowed other people in other parts of the code to just change your numerator and denominator willy-nilly, you have no way of enforcing that rule. Okay? You have no way of enforcing that rule. And so when you have a rule, okay, so this is no longer plain old data. Okay? This is now a ADT is what we call it. Okay. ADT means abstract data type and is quote unquote proper. And it proper. It is proper class design. And I'm putting quotes around it because there's nothing wrong with pods. I'm going to just be real with you guys. A lot of people will get really upset that I said you don't always have to do classes like this because, this is the only way of doing it. But, there's nothing wrong with pods. Okay. Don't you always try to initialize our classes as well? Yes. And so that is the next step. And so how do you, okay, so right now, like what would happen if I made this fraction here? I made this fraction and I said cout f dot get numerator. What would that print? What is that going to print to the screen? 0? It's going to return the value of f's numerator. What is f's numerator initialized to? 2? It's before the set numerator. It does not go backwards in time, right? So if you set the numerator to 2 down there, it is not going to have reverse causality. Technically, 2 could be the answer. It's not going to print uninitialized. Uninitialized is not a value. It's an int. It's going to print something, right? Might be 0. Let's find out. Oh, the answer is negative 2 billion. Oh. No, nobody called that. Okay. Nobody called that. Let's run it again. Oh, it's 100 million. Let's see, what is that? 104 million. Let's run it again. Let's run it again. Let's run it again. Hey. Don't ever have uninitialized variables, kids. It's bad for you. It's like meth. Okay? Meth and math are only one letter apart. Remember that. So just say no to math. Okay? So the never, ever, ever, ever have uninitialized values in your code. It would be amazing if you called it. Yeah, if you got the 2, that would have been spot on. Okay. Never, ever, ever have uninitialized values. And so the way that we can enforce that in ADT is through something called a constructor. So a constructor goes into the public section. A constructor ensures that a class is initialized. Okay. And so it has the name of the class as its function name. So it's a function with the name of the class. And so in this case, we're going to create a function called fraction because the class is called fraction. And what we're going to do is we're going to set numerator and denominator to 0. No return type. See that? It's a function that does not have a return type. Okay. And so what it does is when we create the fraction now, here, this line secretly calls the constructor behind the scenes. And this is the reason why C people hate C++, because C++ has functions that get called and it doesn't appear in the code. C people like to explicitly have an init function and a destroy function. And so the C people know exactly when things are getting initialized. They know exactly when things are getting destroyed. And C++, it will hide function calls like this, and you can't see them. You just have to know that a fraction has a constructor, and the constructor is going to get called as a function call, and it's going to initialize the variables to 0. You just have to know that, and C people hate that, and you know, with good reason. Like if your constructor does something really dumb, right? Like you know, right? Quit. Or, you know, you will be baffled. You're down here, you make a fraction, and it quits your code. You're like, what the hell is going on? Every time I make a fraction, it terminates my program. What the hell is happening? You know, and you wouldn't. You know, people usually don't do things like that, but they might do something like, you know, numerator divided by denominator, right? And so this will be a division by 0, right? And so if your constructor crashes your code, then yeah, or if your destructor is bad, if it crashes your code, you're just like, what the hell is going on? Why is my code crashing when there's no code there? And it's because C++ will secretly insert the constructor when the class gets made, and will secretly insert the destructor when the class goes away. So at the close curly brace, it puts the destructor in there. In this case, it'll use the default constructor, which does nothing. But if you have a crash in your destructor, then when you hit a close curly brace, your code crashes. You're like, what the hell? What the hell is going on? This makes no sense. So good practice is just to have something like that. So have your constructor just initialize your member variables and call it a day. And if you do that, in fact, let's initialize it to, let's not have it initialized to 0/0 because that's not a good fraction, right? Let's initialize it to 1/1, right? Because let's say that we've got a rule. Let's make a rule for this class. Rule number 1. Numerator and denominator must be greater than or equal to 1 at all times. You guys see that? Let's make a rule. Okay. And so we don't initialize it to 0/0 because 0/0 is a dumb fraction, right? Second you try to reduce it, it's going to explode or something, right? So, oh yeah, Mr. Wolf. Yes, very good. You should probably set the denominator to 0 or 0/1. Yeah, that's. But for Egyptian fractions, you can't have a 0 numerator. Hmm. Hmm. Maybe. I don't know. I have to think about that. Doesn't matter. Doesn't matter for our purposes right now. So when you have an ADT, you can enforce rules, and that's why. And this is something I didn't really talk about in CSCI 40, but that's why we go through this whole rigmarole. You might be like tired of writing this code because it's like nothing we're doing here is any better than what we had before. Right? Like what we had before was we just said f dot numerator equals 2, f dot denominator equals 3. Like nothing we've done here has given us anything that we couldn't do before, right? It's just a lot more writing, and a lot of people are just like, why would I bother with the ADT approach? And the answer is because with ADTs you can enforce rules. You can enforce rules, and so when the person tries setting the numerator, you can enforce the rule. If new numerator is less than 1, see out, no, quit. So we're going to enforce rule number 1 here. So if anybody ever calls the set numerator function, and they try passing in a bad number, we're like, no, bad. We kill the program. Sometimes people will write it like this: rule, new numerator must be greater than equal to 1. Something like that. Like you'll sometimes put a note, on the code. With C++20, we're getting better language enforcement of that. So the language itself could be like, you can only pass in a number greater than or equal to 1. But okay, so if we do this now, we're going to print out the numerator first, and then we're going to change the numerator to be 2, and then we're going to print out the numerator again. So if we compile it and run it, you can see the numerator was initialized to 1, and we change the numerator to 2, we print the numerator again, and it prints out 2 right here. Okay. I'm going to print the whole fraction. So when we first create it, it's going to be 1/1. We're going to change it to 2/3, then it's going to print 2/3. Okay. So constructors are very, very useful stuff. It'd be neat to see how to throw an exception for enforcing rules. Sure, let's do that with the set denominator one. Because right now we're not enforcing the rule for denominator, right? So like if I came down here and changed set numerator to be 0, it will be like no and die. But as of right now, if I'm not enforcing the rule for denominator yet, right? So if I change that to be 0, you'll see it just becomes 2/0, which is problematic, right? So let's enforce the rule for denominator as well. Okay. So Muya said let's throw an exception. So sure, let's do that. If new denominator is less than one, throw um, so we're going to throw a const char star in this case. Probably we should throw a runtime error like this. And that is in stood accept. Oh, it's already in there. Look at that. Check you out. All right. So this is how you throw an exception. And so this is kind of the better way of killing your program because main could catch it if it wanted to. And so what this will do is it will throw what's called an exception. And if nobody catches the exception, it kills your program just like this. It's basically the same thing as this, right? It kills your program and it prints to the screen the error message there. Okay. It's kind of a more better way of doing this because there's no way of stopping the code from dying here, right? Whereas with a thrown exception back in main, you could catch it and stop it from killing your program. It does look more professional, yeah, than writing no. Okay. So here's what it looks like when you throw an exception. Terminate called after throwing an instance of stood runtime error. What? Denominator can't be less than 1. So abort, core dumped. So it crashed your program because we did not catch this exception. So that's the professional way of doing it. Okay. And so if you wanted to catch that exception, we could do something like this down here in main. We'd write try. We'll just put it around the denominator one, I guess. Catch runtime error e. Okay, so this is how you catch exceptions. So for those, how many people here have not seen exceptions before? I covered them at the end of CSCI 40, but it's quite possible that some of you guys haven't seen them in a while. Or yeah, so exceptions are an alternative way of returning from a function. So it's this when you say throw, it ends the function. So whatever function you're in, it ends immediately. It's not a return. It's a different way of returning from a function entirely. And what it does is it immediately ends the function, and then it will go up to the function that called it, and it will end that one, and then it will go up to the function above that and end that one, and it keeps going up and up and up until your program is dead. And then then it will print that error message to the screen and crash. It crashes your code, which is a good thing. Right. You want your code to die cleanly and nicely and with a good error message. Now, if you don't want it to kill your program entirely, then you can catch an exception. So at any level, like we could have you can put a try catch block really anywhere, and it catches all exceptions within that try. So try says, hey, try running this code. If it works fine, then just continue on. If they threw an exception, then run this code here. So try will just run this code. It'll try setting the denominator. It will try setting the denominator to 0. And if that throws an exception, it will catch the exception, and it will print bruh to the screen. So it prints out bruh. Okay. So if you've not seen exceptions before, yeah, that's like the 30-second introduction to exceptions. Probably worth reading up on. That was a very fast introduction to exceptions. If you don't understand it, then I'll post a link to you. I don't know how much you're going to come up this semester. We'll post link here. If you want to read more about exceptions, read this. Okay. So exceptions are a nice way of error handling, basically. If you don't get it, then don't worry about it too much right now. But do you guys understand what I'm saying here with the set functions being able to enforce the rule? Does that kind of make sense? Like, yeah, I'll just delete the scary exceptions. We'll just get rid of all this stuff here, and I will just throw in a little standard little thing here. If new denominator is +1, prints no. Okay. Does this make sense? Like, I actually use die functions because I can control what error comes out. Whereas with functions, it has all this boilerplate code on it that I don't like. So I just print bad input and quit. It makes grading it easier. So if they try setting the denominator to 0, then it enforces rule number 1 because we have a check, right? So when we call set denominator, it passes in 0 here. 0 is less than 1, so it's going to print to the screen, no, bad, and quits. Exits the quit function. Do you guys know that? Exit quits. And then if it succeeds, then it sets the denominator to the new denominator. So under normal circumstances, it'll change from 1 to 2/3. But if we change this to, I don't know, -1, then it will error out and die. What does the 1 mean after exit? Great question. So 1 it's the error code. So 1 is the same thing as this. So when have you guys seen in main, like a lot of people put like return 0 here? Have you guys seen that before in main? Have you seen this? Okay, so what does return 0 mean, right? So 0 is actually exit success. That's actually what return 0 is. People just type 0 because it's less typing. And exit 1 is the same thing as exit failure. And so it's an error code. And so when your program terminates, when your program quits, it returns an error code to the operating system. And so if you want to see what the error code is, you can echo $? to the screen. This is kind of obscure stuff now, so maybe don't worry about it. Probably don't worry about it until later. But if it crashes, then when we print the error code, you can see the error code is there. And so it's just a way of C++ telling the operating system, did everything go cool or did we crash or something? So it's just an error code that you return to the operating system. Normally the operating system does absolutely nothing with it. Okay, so most of the time it does absolutely nothing. If you wanted to really bake the noodle of somebody, you could return 100. If you wanted, that's error code 100. It will do absolutely nothing. Right? We run it, error 100 happened, but doesn't do anything. So it's kind of one of those standard things that you return 0 if everything went fine, and you return 1 if something went wrong. There's reasons for that. If you get into shell scripting, for example, my compile shell script. This is Unix shell scripting, by the way. You see that $? So what it does is it'll like run the compiler on your code. It'll run the compiler, and then if your code did not compile because an error code was returned, then it will do something, right? So if you have shell scripting, you usually want to see, was the step, did I run a program? Did it work? Yes. Okay, move on to the next step. Did it work? Yes. Move on to the next step. Did it work? Nope. Stop. Okay. So they're useful in situations like that, but I would say don't worry about it most of the time. Like, doesn't matter. It's just kind of a convention that if something goes wrong, you return one. Can you rewrite the error to do something? Yeah. Well, it's not. Yeah, it's like what I just showed you, that shell script. So you run a program, and then the next program can see, was the previous program successful or not. So if you're scripting things, if you want to run a bunch of steps in series, you can check the error state after every step, and if something ever goes wrong, you just stop, right, instead of continuing on with the rest of it. It's like automation kind of stuff, scripting, macros. Do we have to use brackets around the one? It's a function call. So exit is a function call that quits. And so you just pass in one to it. Exit failure is the same thing as one. Cool. All right. So, yeah, if you're confused about exceptions, I just read that link. We're not doing anything with it immediately. So I wouldn't worry too much about it. The competency exam is due at midnight. So if you haven't taken it yet, make sure you take it. And then I've started pairing people up with the volunteers to help them. We're going to continue on Friday to go through this kind of review of CSCI 40 because I really want all of you guys like at a good level before you move on. I really don't want people crashing and burning. If you have any questions about C++, ask me. That site that I linked you, learncpp.com, is a pretty good overview of C++. It covers the stuff we talk about in 40 pretty well. And so if you haven't programmed in like 7 years, I would just run through that. Like just, you're going to have to sit down. It's like I was thinking about taking Japanese too, right? And so I've been sitting down with the Genki textbook and like rereading the whole thing. It takes a lot of effort. And so just go through it. If there's any sections you're not, if you're not good at something, read it. It's you're gonna have a rough time in 41 if you don't have 40 under your belt. And we're gonna pair you up with tutors and things like that as well. So I care very carefully. I care very carefully. I care very carefully about you guys succeeding. So that's why we're spending all this time in class. And if you have any questions about the fractions homework, I'm around on Discord. So that's it for today, guys. Thank you very much, and good luck, and have fun. The fractions homework is actually kind of fun. It's a little bit, yeah, a little tricky, but it's fun. All right, see you guys.